passive house is approximately 80% more efficient than a regular building. The air tightness is one of the critical factors of a passive house. So if we get most of our heat loss, water damage, and things that go wrong in a house is from air infiltration. So Greg was 10 would be an average, 10 air changes per hour. So that's like all the air in your house is out of the house 10 times an hour. So we're looking at 0.6 air changes an hour, and that's whether the pressure is in or whether the pressure is out. So this is a really airtight house. And then there's the most important thing, which I think people forget, is the primary energy. So this is all the energy it takes to get to your house, all the energy that's wasted on its way to the house, all the energy that's wasted in the house and such. So at 120 kilowatt hours per meter squared is a really tight number, given the number of TVs we have in our homes, given the amount of laundry that we do. So it's a really tight number. So, but it's a goal, right? It's a way to go forward. So when I think about passive house in its very simplest forms, I think of 5 things. So insulation, primary, got to have it, and it's got to be continuous. And if you're doing a passive house, you're thinking around in the Toronto area about twice as much insulation as is required by code. Windows, triple glazed, make the most sense once you're in Canada, with an insulated frame. So if you can get that, because 30% of the loss in a window is around the frame. Air tightness, as I said before, is the key to the whole thing, because you could put as much insulation as you wanted in your house, but you're wasting your money if you're letting it out through the air. Ventilation, keeping the warm air inside. So you can have exhaust fans in your bathroom, which are required by code, but if they're sending all that lovely warm air outside, you have to heat the house up again. So we're talking a ventilation system that's for the whole house, a little breath of air, that if it's minus 20 outside, it comes in at 94% efficiency. That means about 18 degrees when it arrives in the house. And then having 0 thermal bridges. And a thermal bridge is when something inside the house passes through the exterior wall of the house and takes heat with it. So a cantilever deck, metal. If you have a big metal beam that's coming from inside to outside, that would be considered a thermal bridge. So this is the first, and all of these things, these 5 things, if you just do 1, your house is going to get moldy. If you just do 2, your house is going to get moldy. If you do them all at the same rate and with the same intensity, that's when they work together, because each one of them is related to another. So it's more like a holistic way of thinking about your house. So this is actually a straw bale house in the city of Toronto. So it's showing some of the insulation that's possible, and we have examples of straw bale over on the table. You can check it out. Insulation is insulation is insulation. The R value is what it is. So you can choose a straw bale, you can choose a rock salt material. You just need lots of it. And continuous. So this is showing how we're trying to make it continuous. This is another image of rammed earth. The lovely Sylvia is here from Aerocure Rammed Earth. And this shows how we've got insulation from the foundation all the way up to the roof through the middle of the building, and it's continuous. This picture shows my neighbor's house. They love this picture. It's glowing in the dark because it's heating the outside. And this is my garage, and that's my bathroom above my garage. But you can't tell in the wall where the heated space is or where the garage is because it's so much bloody insulation. And it's airtight. So the only thing we can see now are the old awful Pella windows that I bought and I couldn't afford to replace. Gives you an idea of what it does. So here are some of the window opportunities here in your house. I mean, these are the holes in your building. And North American windows don't work so well. So this is like a German triple glazed window. We also have examples outside. And the frame is considered, it's insulated. They're airtight. The hardware works again and again and is infinitely adjustable. So if you're going to be putting beautiful windows on your house, that's what I suggest. And which house is the passive house? It's the blue one in the middle. So once again, with the IR photography, infrared photography, you can see how much of a difference really good windows makes. One of the more important things about windows is you can sit beside it and you're not getting that cold air of that draft beside it. That's another reason for using these windows. Oh, and here's my favorite picture. Before and after air sealing and insulation. Yeah, don't need to say anything about this one. So this is, Building Science 101, our favorite picture on how air tightness is really important and that 90% of water and heat and all that stuff travels through the smallest holes in your building. Ventilation. This is another one of my little favorite little pictures. What we used to do is we used to have big brick houses, and big furnaces was the fireplace. And they dried out because we heated the outside and the masonry with it. And then we got really complicated. I think this is the 1980s. And we put a ton of stuff in our buildings to try and make them do what we wanted them to do. And now we're kind of looking forward and looking back, saying, let's bring the sun in. That's what the passive part of Passive House is. Let's use as much stuff that's not moving to make the house do what it's supposed to do. And then have a smaller mechanical system, have a smaller ventilation system. So we're hoping that, maybe in the forward, we go forward by going a little bit back. Operable windows. There you go. You can have there's a whole thing about Passive House not being allowed to have operable windows, which is just a joke. Everybody should have operable windows. But yeah, no, this is just one of the passive, this is a retrofit of a cottage that we did. So we wrapped this in insulation and straw bale. So it's talking about the lungs of the building. So there's something called an energy recovery ventilator or a heat recovery ventilator that is now required by law for new buildings, but even in existing buildings, if you're going to do a retrofit, you want to have that lung in the building bringing in fresh air all the time so that even the toxic materials you already have in your house are being, the air is getting exchanged, but we don't want to lose all that heat when it's exchanging through an open window. So as I said before, with a 94% energy efficient heat recovery ventilator, you're going to get that fresh air all the time. It's still breathing the building, but you're not letting it out so that the air is willy-nilly going through the insulation layer and creating more like an air filter. So here we go there. I think this really is my favorite example of a building that is just one big radiator put on the vertical. You can see that all the fins are just radiating the heat out from inside the building to give you an idea of what a really bad thermal bridge is. And thermal bridge free, we're back to the rammed earth, one of my favorite materials to use, where through the middle of the building and around the corner of every single corner in the building, that insulation is continuous. There are no studs in there in this case. So you actually get more insulation in the corners of this type of building than you would in a wood stud building, because you're going to have, there's no structure at that corner. It's just insulation and the structures on either side of it. And then Passive House is a path, or is it a destination? Or is it both? And that depends on the project. So the requirements of Passive House are very stringent. The requirements for third-party testing, it's a very good idea. But sometimes if you're doing a renovation and your building doesn't face south, or you have some other opportunity and you can't actually get as far as you'd like to go, take the path there and take all those 5 elements with you on that path and get as far as you can go. And then these are just some examples of some of the highly efficient buildings that I like to design. My company is Stone's Throw Design. This shows some opportunities with the German windows. The middle one here is a straw bale house. In fact, all 3 of them are straw bale houses, and you can't tell. These are some exteriors of some buildings that we've done in rammed earth. This one here is a building in Witchwood Park in which we gutted the entire building. We actually took the inside of the building out, all the wood, and then built a new house inside. It was the most it was a heritage neighborhood. We couldn't take the outside. We couldn't do anything with it. We weren't allowed. So building a new wood frame house on the inside was, in this instance, the most common sense thing to do. On this one, we added a 2-story straw bale rear addition in the city of Toronto in the Beaches. And then the last one there is the first insulated rammed earth house in Ontario. Short and sweet. Thank you. How's the market for this? Well, in my firm, I work about full-time, and all of my houses are done to a high efficiency level. I would say I follow the path more than the destination, but I think that there is a market for this stuff, yeah.
We're seeing it in affordable new housing. A lot of municipalities are taking it up because obviously if you have a great passive building, you have really low bills and great comfort and great dignity for the people inside the building. So yeah, there's...
Actually, I have a report from the city of Toronto. Their Toronto housing will be, in the future, going to the passive house standard. So any new buildings that way. Yes? How much more expensive is it to build passive house than to regular house? Well, at this time, I would say it's where you're putting money that's in a different place than if you were building a regular house. So when we buy a house, it comes with the mortgage and the monthly utility bills. So if you're buying a passive house, you still have the mortgage and it might be slightly higher because you're paying for higher quality. You know, you're building a Tesla, not a Kia. And but the monthly bills of running that house are much, much, much lower. So the overall cost in terms of carrying that house, they could be equal. And what I like to say is in the right project, the money that you put into insulation, windows, reduces the size of the heating and cooling system for that house. So where I say is at 50 kilowatt hours per meter squared, you've got to build the big system even though you're not using it all. At 30 kilowatt hours per meter squared, you can kind of start to think about alternatives to that, like maybe mini splits and things like that. And when you get to 15, which is the passive house standard, that's where you can use an electric baseboard, and the $500 that you spent on doing the whole house, you can get a lot of energy out of that. So even if your bills are slightly higher from that. And so there's a range of ways of thinking about it. That may not be the perfect solution in every situation. It may make more sense to have heating and cooling in a split mini, but you're getting down to the levels of heating and cooling where those things start to make sense. So that's what I would say. It's not a difference in price overall. It's a difference in price on what you're paying for. And what is a split mini? A split mini are those, Mitsubishi makes them and Fujitsu. They're those little air conditioning units that people are putting on the inside that don't have ducts, but they're actually also meant for heating. So you can use those tiny little systems for both heating and cooling. So in a small enough heating and cooling load, they can be the heating system for the house. Anything else? Great. Thank you very much.